All right, in this video we're going to look at the quiz review for Standard 2. The first question says, how many grams are in 4.6 moles of calcium chloride? So we always start by writing out our given, which is 4.6 moles. Okay, now next we need to convert our moles into grams. The question is asking for grams. So to go from moles to grams, we always use the molar mass. Now if you look here, moles are given, so moles need to go down into the denominator. So for every 1 mole of calcium chloride, our molar mass we can find by taking this here, looking up the values on the periodic table, so if you look up calcium on the periodic table, the value of calcium is 40.08 grams. And for chloride, or chlorine rather, there's 2 of them, and its molar mass is 35.45 grams. Okay, so the total molar mass is 110.98 grams per mole. So that molar mass we're going to use right here. And when we multiply this out on our calculator, we get 510.508. And then looking at what's given here, we have 2 sig figs. So I'm going to underline the first 2 numbers and then look at the next, first 2 digits rather. So when we go to round this, this is going to be just 510, no decimal. If I added a decimal there, that would be 3 sig figs. This is just 510 grams. All right, second question asks us to go from grams to molecules. So just look at the first question. Let's go ahead and start out with what we're given. Okay, now to go from grams to molecules, we don't have a direct conversion. We have to first convert to moles. So let's look at what we're given. Our units that we're given are grams of oxygen. So grams need to go in the denominator. If you look up oxygen on the periodic table, the molar mass of oxygen is 16, but there are 2 of them. So the molar mass will be 32 grams. Oops, I said that would go on the bottom. And that's how many grams are in 1 mole. Now, the question did ask us for molecules, so we're going to need another conversion to go from moles to molecules. So I want you to notice here that moles are in the numerator, so we're going to need moles of oxygen in the denominator of our next conversion. So for every 1 mole of oxygen, we have 6.022 times 10 to the 23rd molecules. And that will give us 6.69725 times 10 to the 23rd. Going from left to right, if you notice we have 3 sig figs here, so going from left to right, let's underline the first 3 numbers, first 3 digits, and look at the next. So I'm going to go ahead and round this up to 6.70 times 10 to the 23rd molecules of O2. All right. Question number 3 asks us to go to moles, and we're given grams. So again, we're going to start with the given, so 45 grams of carbon dioxide. And the units that were given in the question are grams of carbon dioxide, so those are going to go in the denominator, grams rather. So we're going to need the molar mass. And let's go ahead and look this up. So carbon on the periodic table is 12.01, And then oxygen, there's 2 of them, and there's 16 apiece. So that's going to give us a molar mass of 44.01 grams per mole. So the grams are going to go in the denominator here. And there are 44.01 grams for every 1 mole of carbon dioxide. And when I multiply this out, I get 1.02249. And we have 2 sig figs in our given, so I need 2 sig figs in my answer. Oops. So looking at the next digit, oops, I made a mistake. Because we were not given 45, we were given 45.0. So we're going to actually look at the 1.02 and then look at the next 2. So the final answer will be 1.02 moles of carbon dioxide. All right, question number 4 is going to be a little more complicated. Question number 4, we are going from 5.5 grams of copper chloride to grams of sodium chloride. So I know that I'm going to need the molar mass of both, so I'm going to go ahead and start by finding both of those. So the molar mass of NaCl is 58.44. So I just looked up sodium and chlorine on the periodic table, added them together. And then the molar mass of copper chloride is 134.45 grams. So let's start with our given, which is 5.5 grams of copper chloride, and we are given grams in the given, so grams of copper chloride are going to need to go in the denominator of our first conversion. Okay, and that's how many grams are in 1 mole. Okay, so now that we're in moles, we can go ahead and do our comparison, our mole ratio. So we're looking at copper chloride, and we're looking at sodium chloride. So we're already in moles of copper chloride, so I want to have moles of copper chloride in the denominator. There is not a number in front, so we assume that there are just 1 mole. Or there is a 1. We're not assuming anything. And then in our second, in what we're going to, the sodium chloride, there's a 2, so there's a 2 moles here. Okay, and we're going to need another conversion, because now we're in moles of sodium chloride. Now we need to convert that to grams, because the question's asking us for grams. So if you look, moles are in the numerator of our last conversion. So for every 1 mole of sodium chloride, we're going to have 58.44 grams. And then again is the molar mass. So when I multiply this out of my calculator, I get 4.7812. There are 2 sig figs in my given, so I underline the first 2 digits and look at the third. So I'm going to round this to 4.8 grams of sodium chloride. All right, number 5. Number 5, we are given that we have 3.78 moles, and we want to go to moles. So moles to moles is easy. We're just going to use that mole ratio. So we've got 3.78 moles. And let me go ahead and highlight what we're looking at. Okay, so we're already in moles. We don't have to convert anything into moles. So we're just going to do our mole ratio here. So in the question, we're starting with sodium NO3. I think that's nitrate. So for every 2 moles we have 2 moles of sodium chloride. You really don't even need to use your calculator here because 2 over 2 is the same as 1 over 1. Any number times 1 is just going to be that number again. All right, number 6. Number 6 says how many atoms are in 7.27 moles of carbon. So we're given moles and we want to go to atoms. Again, since we're already starting in moles, we don't have to do any conversions right off the bat. So 7.27 moles of carbon. Here we are just going to multiply our moles. So we're in moles of carbon. So for every 1 mole of carbon, we use Avogadro's number, which is 6.02 times 10 to the 23rd. That's how many atoms of carbon are in 1 mole. And when I multiply this out, I get 4.37654 times 10 to the 24th. All right, we have 3 sig figs in our given, so I'm going to underline the first 3 digits and look at the 4th. So when I go to round this is going to be 4.38 times 10 to the 24th, and these are atoms of carbon. Okay. Number 7, we are going from grams of sodium chloride to grams of sodium carbonate. Since we're going grams to grams, I'm going to need molar masses of each. So let's go ahead and write this out. So we've got our first one here, which will be 105.99. And our second one, our sodium chloride, is going to be 58.44. And again, I found these by looking up each individual piece on the periodic table, so the value of sodium, the value of chlorine, and I added those masses together. Okay, so let's go ahead and start out with what we're given, which is 1.5 grams. Okay, so since grams are in our given, those grams need to go in the denominator. So this is going to be our molar mass. Anytime we go from grams to moles, we use the molar mass. So 58.44 grams of sodium chloride. And that's how many grams are in 1 mole. Okay, next we're going to go from we're going to go from moles of sodium chloride to moles of sodium carbonate. So let me highlight what we're looking at in the question. So if you look at the question, for every 2 moles of sodium chloride, we have 1 mole of sodium carbonate. Okay, and then if you look here, we are in moles of sodium carbonate. So those moles are going to need to go down in the bottom. So for every 1 mole of sodium carbonate, to go back to grams, because that's what the question's asking for, we need our molar mass. So we already calculated this earlier. It's 105.99 grams. Okay, and when I calculate this out on my calculator, I get 1.36024. We have 2 numbers in our, or 2 digits rather, that are significant in our given. So I'm going to underline the first 2 digits and look at the third. So I'm going to go ahead and round this up to 1.4 grams of sodium carbonate. So Na2CO3. Okay. Number 8. Number 8, we are given atoms, and we need to go to grams. So let's go ahead and start with what we're given. We don't have a direct conversion to go from atoms to grams. We have to first go to moles. So anytime we go from atoms to moles, we use Avogadro's number, 6.022 times 10 to the 23rd. atoms of aluminum, and that's how many atoms of aluminum are in 1 mole of aluminum. Now to go from moles to grams, because again, this is what the question's asking for, we need to use that molar mass. So we're currently in moles of aluminum. So for every 1 mole of aluminum, if you look up aluminum on the periodic table, its molar mass is 26.98 grams of aluminum. And this is going to be 30.206. And in the question, we're given 3 significant figures. So we're going to look at the first 3 digits and then look at the fourth. So this will just be 30.2 grams of aluminum. All right, number 9. Number 9, we are given moles, and we want to go to moles. So this type of question is just a mole ratio. So we are given 4.5 moles of oxygen, and we want to go to moles of aluminum. So we're going to use that mole ratio. So let's go ahead and highlight what we're looking at in the question. So we are currently in moles of oxygen. So moles of oxygen are going to go in the denominator. We have 3 moles of oxygen for every 4 moles of aluminum. And when you multiply this out on your calculator, you get 6, like 6 even. But we have 2 sig figs in our given, so we need to turn 6 into 2 sig figs. So this will actually be 6.0 moles of aluminum. Okay, we got 2 more left. For number 10, it says how many molecules of aluminum oxide, so molecules, are formed when we react 7.3 grams of aluminum. So let's start by writing out what we're given. This is always our process. Always start with the given. And then we need to first convert this into moles. So for aluminum, if you look that up on the periodic table, and again, we're given grams of aluminum, so the grams are going to need to go in the denominator. 26.98 grams of aluminum, and that's how many grams are in 1 mole of aluminum. Next, we're going to go ahead and do our mole ratio. So we're looking at aluminum, and we're looking at aluminum oxide. So we are currently in moles of aluminum. Moles of aluminum are going to need to go in the denominator. So if you look at our chemical reaction here, there are 4 moles of aluminum for every 2 moles of aluminum oxide. And then our last conversion, we need to go from moles of aluminum oxide to molecules. So since we left off with moles of aluminum oxide, we have 1 mole of aluminum oxide, and for every 1 mole we have 6.022 times 10 to the 23rd molecules and when I multiply this out on my calculator, I get 8.1441 times 10 to the 22nd. And going back to our given, we have 2 sig figs here. So I'm going to underline the first 2 digits and look at the third. So when I go to round this, this will be 8.1 times 10 to the 22nd. And these are molecules of Al2O3. Perfect. Last one. So in the last question, we are given that we have atoms of chlorine, and we want to go to grams of sodium chloride. So we're going to go ahead and start with our given, which is 1.43 times 10 to the 23rd atoms of chlorine. To go from atoms to moles, we need to use Avogadro's number. And since our given has the atoms here, we need to put that down here. So Avogadro's number is going to go in the denominator. 6.022 times 10 to the 23rd atoms of chlorine. And that's how many atoms are in 1 mole of chlorine. Okay, so now we're in moles. So our next step is to do our mole ratio. So we're going from chlorine to sodium chloride. So we kind of left off with chlorine. So looking at our equation here, again, if there's nothing in front of it, there's a 1. So for every 1 mole of chlorine, we have 2 moles of sodium chloride. And the question is asking for grams. So we need to take our sodium chloride, our moles of sodium chloride, and we need to turn that into grams. So for every 1 mole of sodium chloride, we need to figure out the molar mass. The molar mass, oops. So on the periodic table, we looked this up. Sodium's 22.98, and then chlorine is 35.45. We add those together, and we get 58.44 grams. So 58.44 grams. And when I multiply that out, I get 27.7638. Looking at our answer, looking at our given, we have 3 sig figs. So underline the first 3 figures and look at the fourth. So I'm going to round this to 27.8 grams of sodium chloride. And that was the last problem.